Hey guys, I'm back with the second part of the chapter electric current. In this part, we will begin with resistance. Let us revise what is resistance. Resistance is potential difference upon electric current. Now, in this part, we are going to see how to use electrical resistance in the circuits. So, we will see series circuit and then the parallel circuit. Let me tell you, this is the symbol of resistance. We represent resistance in the circuit this way. Okay. Now let us see the series resistance. The code is in series resistance or in series combination. The current in all the resistance is going to be same. Okay, and the potential difference is going to divide. The total potential difference that the cell will provide will be divided in the resistance. Okay. And series resistance is represented this way. All the resistance in same line, or one end of resistor connected to the terminal of the cell and other end is connected to next resistor. This is the way how we'll identify which one is a series circuit. As I told you, in series circuit, voltage gets divided. So total voltage supplied by the cell, that is V, is equal to V1, that is provided to the resistance R1, and V2 to the R2. So we get the equation V is equal to V1 plus V2. Now, as I told you earlier, that potential difference is equal to I into R, that is derived from Ohm's law. Okay, we'll apply this here. As I told you, current is constant, so we are going to get an equation IR, that is the total resistance, is equal to IR1 plus IR2. Okay, and then we are going to cancel I from the right hand side and left hand side. So we get the final equation for series combination of resistors, that is equal to R is equal to R1 plus R2. So this applies to n number of resistors. For example, if there are 3 resistors, R is equal to R1 plus R2 plus R3. If there are n resistors, what would you do is R is equal to R1 plus R2 plus R3 up to infinity. Yes? So this means that resistance, total resistance will be equal to NR. N is what? The total number of resistors. Let me tell you, series resistor combination मध्ये काय होतं की जे टोटल रेजिस्टन्स आहे तो खूप इन्क्रीज होतो फ्रॉम द इंडिव्हिज्युअल रेजिस्टन्स. म्हणजे R1 पेक्षा जास्त, R2 पेक्षा जास्त टोटल रेजिस्टन्स इन्क्रीज होतो इन अ सिरीज कॉम्बिनेशन. ॲड अप झाल्यामुळे इट ऑलवेज increases. Okay, now this was all about the series combination of resistors. Now let us take a look at the parallel combination of resistors. What is parallel combination of resistors? In this combination, basically both the terminals of the resistors are connected to each other and then they are connected to the terminals of the cell. You can see in the diagram. Then the code for parallel circuit is that the potential here remains the same for the 2 resistors and current gets divided. Now here the potential supplied by the battery BV and the same will be for R1 and R2, that is V. Okay, समजतंय म्हणजे potential will be same and the current is going to add. Current which will come from the battery will go, I1 will go to R1 and I2 will go into the R2. So, आपण equation जर बनवलं, we get a equation current I, total current is equal to I1 plus R2. If you remember from the Ohm's law, we saw current I is equal to potential difference upon resistance. Now, आपण हे इथं substitute करूया. Okay. So, V upon R will be equal to, voltage is constant, so V upon R1 plus V upon R2. Yes? Now, we are going to cancel V from RHS and LHS. So, we are going to get 1 upon R is equal to 1 upon R1 plus 1 upon R2. So, this is the final equation for resistance in parallel combination. This equation applies to n number of resistors as in the first case, that is in series resistors. For example, if there are 3 resistors in parallel, we get total resistance 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Okay, now if there are n number of resistors in parallel, what will you do is a resistor equal to R upon n. For this, the resistance of each resistor should be equal to R. Okay, now let me tell you, पॅरलल कॉम्बिनेशन मध्ये जो टोटल रेजिस्टन्स आहे तो कमी होतो, डिवाइड होतो. म्हणजे इंडिव्हिज्युअल जो सगळ्यात स्मॉलेस्ट रेजिस्टन्स असेल R1 किंवा R2 पैकी त्याच्यापेक्षाही कमी टोटल रेजिस्टन्स येणार आहे. दॅट इज अ पॅरलल कॉम्बिनेशन. ओके, now let me tell you the circuits used in your homes are the parallel ones. That is, the domestic circuits are parallel ones. Now why parallel ones and why not the series? Now there are some disadvantages that series circuits have, and parallel circuits overcome these disadvantages. So we will obviously use parallel circuits. Let me tell you the disadvantages of the series circuits. The first most disadvantage of the series circuit is that if one appliance in your home gets fused or you switch off, then all other appliances will get switched off. म्हणजे काय, आता सपोज टीव्ही आहे, फ्रिज आहे, बल्ब आहे. if the bulb gets fused, you cannot use TV, fridge, nothing else. Okay. Second disadvantage है कि you have to operate all the appliances on only one switch. That is the TV, fridge असेल तर यूज करायचं असेल तर सगळंच यूज करावं लागेल, नाहीतर तुम्ही काहीच यूज नाही करू शकत. This is a disadvantage in series circuit. And third disadvantage is, I told you कि resistance जो है, total resistance in series circuit तो वाढतो from the individual resistances. त्याच्यामुळे obviously काय होणार आहे, current will get decreased. So आपल्याला तसं नको आहे. And fourth disadvantage is that all the appliances that we use in our homes cannot be used at a constant voltage. As I told you, series मध्ये काय होतं की voltage divide होतं आणि current constant राहतो. But in the house we have to operate all the things, all the appliances at a constant voltage. तर हे सगळे होते disadvantages of the series circuits. Now we will take a look at the advantages that the parallel circuit provides, and so we use the parallel circuits in our homes. The first most advantage of the parallel circuit is that all the appliances that we use in our home, we can use it individually. That is, at a time we can use only TV or only the fridge. आपल्याला fridge नको आहे, fridge फक्त बंद केला, we can use TV. Okay, and the second advantage is that we can operate all the appliances with their individual switches. We can off one appliance at one time and use the other. म्हणजे असं नाही की एकाच वेळेला सगळं यूज करायला हवंय और काहीच यूज नाही करू शकत. You can use individually the appliances. Okay, and the third the advantage of the parallel circuit is that resistance decrease होतो. Total resistance है individual resistance पेक्षाही कमी येतो, त्याच्यामुळे obviously current increase होणार आहे. So we need that situation. And domestic circuits मध्ये आपल्याला appliances सगळे constant voltage वरती पाहिजे, which is provided by the parallel circuit. So we use parallel circuits in our house. You must know की आपल्याला जे मेन बोर्ड आहे तिथून व्होल्टेज सप्लाय केवढा येतो, दॅट इज 220 वोल्ट अप्रॉक्सिमेटली एवढाच येतो सगळ्यांना. सो ऑल द अप्लायन्सेस आपल्या घरात जेवढे असतात ते सगळे 220 वोल्ट वरती ऑपरेट करण्यासाठी डिझाइन केले जातात. नाउ लेट अस सी व्हाट इज इलेक्ट्रिकल पॉवर. Power is defined as work done per unit time. So electrical power is equal to work done upon time for it is done. The unit of electrical power is watt, represented as W. We can define 1 watt as 1 joule of work done in 1 second. So that is 1 watt. Now we will see how can we calculate power in an electrical circuit. Power in an electrical circuit can be calculated as potential difference into current I. Now we get the equation P is equal to V. We can also substitute V is equal to IR. So we get P is equal to I square R. Or if we substitute I is equal to V upon R, then we get third equation P is equal to V square by R. So in total, 3 equations set for calculating power in electrical circuit. Let us see. The first is P is equal to VI. The second is P is equal to I square R. And the third is P is equal to V square by R. And the unit of the power, as I told you, is watt. Now there is another term that you should know, that is electrical energy. How is it defined? Electrical energy is the power consumed by an appliance in the time for which it is used. For example, आता तुम्ही TV बघितला 2 तास, तर 2 तासात सपोज 100 वॅट पॉवर कंझ्युम झालं, मग इलेक्ट्रिकल एनर्जी किती झाली? 100 वॅट अपॉन 2 hours. So that is electrical energy. But electrical energyचा सिग्निफिकन्स काय? तर बघा, जे तुम्हाला लाईट बिल येतं दर महिन्याला, त्याच्यामध्ये जे बिल तुम्ही पे करता ते इलेक्ट्रिक करंट यूज केल्याबद्दल नाही, तर इलेक्ट्रिकल एनर्जी यूज केल्याबद्दल बिल भरता. आता तुम्ही म्हणाल हे काय, तर इलेक्ट्रिकल एनर्जी किलोवॅट आवर मध्ये कॅल्क्युलेट करून तुम्हाला बिल पाठवतात. आता किलोवॅट आवर म्हणजे काय? 1 kilowatt is the electrical energy used by the appliance having a power rating of 1 kilowatt and used for 1 hour. म्हणजे एखादा appliance त्याचं power rating किती हवं? 1 kilowatt. 1 kilowatt is equal to 1000 watts. 1 kilowatt power rating and used for 1 hour. The 1 unit in the electricity bill equals to 1 kilowatt hour. Okay, this was all about electrical energy. Now we are going to see what are the effects of the electric current. Electric currents have various effects, for example magnetic, thermal. Now for the time being we are going to take a look at the thermal effects of electric current. आता thermal effects म्हणजे काय? Heat produce करतो electric conductor. का heat produce करतो? Electric current when passed through a conductor having a high resistance, for example nichrome wire, then it gets heated and produces heat. आता इलेक्ट्रिक करंट जेव्हा खूप जास्त रेजिस्टन्स असलेल्या वायर मधून आपण पास केला तर the wire gets heated. तर हे हीट काय? That is a heat is a type of energy. So unit of heat is going to be joule. What is the formula? Formula for calculating heat is equal to I square R into T. So if we need to calculate heat produced in an electrical circuit, we will calculate it as I square R into T. Now if we substitute here I with V upon R, we get the equation V square upon R multiplied by T. Or we can also use the equation VIT. So these are the equations we can calculate the heat produced in an electrical circuit. Now this heating effect of electrical circuit can be used in various ways. It has applications. आता आपण डेली लाईफ मध्ये काही अप्लायन्सेस यूज करतो. फॉर एक्झाम्पल द electrical kettle we use, or the electrical iron we use in our home, electrical heater. All this depends upon this heating effect of electrical conductors. And the second use of electrical heating effect is the tungsten wire or the fuse wire. This tungsten wire that we use in electrical bulbs, this has a very high melting point. तर आता हे जे टंगस्टन वायर आहे ते हीट झाल्यानंतर लाईट प्रोड्यूस करतो. सो दिस इज अ युटिलायझेशन ऑफ हीटिंग इफेक्ट ऑफ द इलेक्ट्रिकल कंडक्टर. अजून एक ह्याचं ॲप्लिकेशन आहे की एखाद्या बल्बमध्ये इफ वी वॉन्ट टू प्रोटेक्ट इट फ्रॉम गेटिंग बर्स्ट ड्यू टू हाय टेम्परेचर, खूप टेम्परेचर वाढलं की बल्ब कधी कधी फुटतात. मग तसं न होऊ देण्यासाठी वी कॅन यूज द वायर्स in the bulb which have a very low melting point. So जर टेम्परेचर खूप वाढलं तर वायर मेल्ट होईल and the circuit will break आणि करंट फ्लो स्टॉप होईल. त्याच्यामुळे टेम्परेचर खूप वाढणार नाही and the bulb will not get burst due to high temperature. So these were the effects or the applications of heating effect of electrical circuits. So guys, this was all about the chapter electric current. Watch the video. If you have any doubts, tell me in the comments section. You will get a dedicated video about how to solve the complicated electrical circuits. If you like the video, please like, share and subscribe to my channel.